Sent to the future from the year 2000 by a glitch due to the Millennium Bug, I'm adapting to thrive in the peculiar conditions of the 2020s. Join me in a multimedia extravaganza as we surf the World Wide Web, catch up on 2 decades of video games and mess around with creative tools new and old. I'm Millennium Cyborg, welcome to the new millennium. I feel like I need a slightly different set of transitions for when I'm doing a development stream, because I don't have like a camera swoosh coming into the desk the way I have on a gaming stream. Maybe I need to bring back the TV transition somehow. All right, let's get some music back on. So, what are we up to today? I've had a problem that I've been trying to tackle properly for quite some time. One of the very first things that I made for the channel was a looping video in Bryce. Let me bring that in now. On this one, it's still my BRB screen. And if we wait just a few seconds, you'll see the animation is looping, but after a few seconds, when it hits the loop point, it's very noticeable that it's jumping. It's jumping because the scroll positions for the sky and water textures that give it an animation, those jump back to the point they were at before. Now, that's not something I can really avoid. I could have made a much longer video and so push back the point where it noticeably jumps when it loops. But that's not solving the fundamental issue. The water and cloud textures are, theoretically infinite procedural textures with an offset applied over time. There's not a point within texture itself where it will repeat. I could have done some video editing and had one of the textures, one of the ends of the video fade into the other, but that's also quite noticeable. And the problem persisted in the next video I did for my intro as well. I made that one a little longer. It was a 15-second video, I think. It took 3 entire days to render. That's part of what put me on the path. This was all in Bryce, and this was part of what put me on the path to making my own ray traced renderer in real time using RTX DirectX ray tracing. So here we have it, you know, the now standard scene that I start off the streams with. Ray traced in real time with procedural textures, not visibly looping. And the way I solved it here is that it's still looping. It's just not a longer time interval that it loops. I think I have it set to something like 1 minute right now. So unless you're looking at that precise moment, you might not notice it at all. That worked fine for quite some time actually, as I was fiddling. Moonkay, hi. Nice to see you. Yes. So this what you're seeing here is a Unity project that I created. Some would say cobbled together. It's a recreation of a scene that I made in Bryce, and the render pipeline is written using the Unity scriptable render pipeline functionality. Bryce is a program from the mid-90s, I think, the original version. It's a ray tracer. I'll bring back the actual Bryce scene. This is made in Bryce, although it's a higher resolution render than you would have had at the time. It lets you create procedural terrains, procedural cloud textures, water textures, everything ray traced. Not at all real time. Every frame takes an absolute age to render. And also the techniques used in ray tracing in the mid to late 90s, quite different to the sort of ray tracing that you'll see done nowadays. So in fact, my Unity render pipeline replicates those old algorithms because I like the look of the old style ray tracing rather than the, you know, modern style. So for instance, I wouldn't be able to just open up an Unreal or Unity, you know, high definition render pipeline project and do something quite like this. Oh, thank you. Yeah, it's all about the aesthetic. I think a 1660 probably doesn't have the RTX ray tracing, right? What I'm doing is very, very wasteful. I'm using a 3070 to render this right now. It's not the efficient way of doing things. I've got some optimizations in mind that are a long-term project, but well, thank you. I'm glad you enjoy it. So the hacks I've got in for looping the animation of this cloud and water, they work for now, but I run into a problem when it comes to switching the sky and water environment and the speed at which they run. So the first time I ran into this, I'm going to bring in some other elements now in the scene and move over to, I'll bring in the right music as well. So we're going to bring in hang on, I'm gonna just also bring in my avatar tracking just so it doesn't T-pose. Okay, make sure it's sending to the right place. That needs to be local IP. Okay, let's try it. So I'm going to bring in a set of environment settings I use for the Futuristic Racing Friday show, which I really need to get back to actually running. There's a lot of games to play. So that's turned on, and next I need to enable the camera loop and then switch the sky over. And as soon as I switch the sky, you'll see it goes back. It runs forward, it goes backwards, and there we go. This is what it looks like during the intro of Futuristic Racing Friday. So it looks like I'm rushing along in the vehicle just by changing the speed of the clouds and the water. But during the transition, it kind of runs backwards and goes at all kinds of weird speeds. Why do I like the early noughts? I don't know. And just aesthetically, I guess I was really into the style back then. I was digging through some of my old projects. It's kind of when I first jumped into creating some of my own artistic content. Not that I was very good, but I messed around with Bryce back in the day, and it was at the same time that I was thinking about VTubing, I found some of that early work I did and got inspired. Could I do what with the sound of the music? What do you mean? So I've got the sound of the music is feeding into the spectrum analyzer in the background. And the camera movement is just like every end seconds it's switching camera angles. Then that animation is moved. Yeah, I've got, in theory, I could add more animation based on the music. So I'm using a plugin that takes the music and translates it into a texture of each part of the spectrum. So in theory, I could feed that back into any old kind of thing, whatever I decide to program. So what I'm looking for a solution to is that switch, right, between the normal sky and the high speed sky. I want to make it look like what you'd expect, like the sky just speeds up. So if I go back to the regular sky, okay, well that wasn't very visible. Let me go back. Let me take over the camera. Go back to this view. Alright, and then switch the sky back to the regular speed sky. Interesting. The clouds are completely gone. I wonder why. I think it's something to do with how I did the time, the handling of time, but I'm not sure what it's doing. Let's see. You want to make something like this, but 90s, more aesthetic metal. You want to have music stream where your music goes with what's going on. How much like what sort of tools are you comfortable with? I mean, I could tell you about how to program something like that from scratch. One thing you might want to look into, right, that's quite a powerful tool is called Touch Designer. And there's a guy called Sushi Dragon who uses that for some really impressive effects during a stream. Yeah. There are components in Touch Designer. It's a node-based tool, and there are components where you can bring in, you know, sound analysis, and then just plug that into all kinds of visual effects, and you kind of compose nodes together to produce a final scene. You could pipe that into OBS, or I think Sushi Dragon directly streams from Touch Designer. I've fiddled with it a little. I'm not super familiar with it myself, but I've seen some impressive things done with it. Right, let me just restart this scene. Okay. So, one reason why there's a big... Okay, the reason why things run backwards when I'm switching from one of the skies to the other and one of the speeds of the water to the other is that I'm not computing the current scroll position. I'm passing the current time into the shader that draws the clouds, the sky, and the water. And so it recomputes the position of the sky as if the current speed had been the speed for all time. Which means that as you vary the speed, you're actually affecting the position by quite massive amounts. So, one of the things I need to do is make it so that I can maintain the current scroll position. Hang on, this isn't my... It's now moved on to the wrong playlist. Just a moment. So you're learning HTML and CSS, your chat books, WWF attitude era metal, 90s music video pop-up alerts, yeah. T-shirt T-shirt in green screen that plays another music video. That sounds very fun. Within OBS, I don't know of much in terms of many tools that could help you have animations reacting to music. There's the Spectralizer plugin that lets you do a spectrum visualization, but that's all that I know. So that's why I'm thinking of a tool like Touch Designer. And if you follow some tutorials, depending on what you want to do, I mean, it might not be that complicated. But within OBS itself, it's potentially quite limited. And in HTML and CSS, I mean, I'm sure there are JavaScript libraries that do all kinds of things, but that's one area of programming I've kept away from for the most part. Yeah, it's tough making streams engaging. I've still not even set up proper, Twitch reactive stuff as part of my app. I'm sure I'll get around to it eventually. All right. I'm gonna start actually opening up some code. Should bring up an example of the noise that underlies all of this. We had one earlier. There we go. What is this program? This right now is Unity, and then the other one is Visual Studio 2019, in which I'm writing C# for the CPU side code and HLSL for the shaders. Yeah. And then I've got Krita open for doing some drawings and explanations. So where should I start? So you can see the clouds in the background, and those are generated using a very old school but still used procedural technique. And the more accurate name for it would be value noise. So the idea, I've not used Krita very much yet, but I tried to do this in GIMP before the stream and it was just not much fun. So let's see how it goes in Krita. Oh yeah, you can definitely go overboard and max out your GPU with shader effects. So in the background of my scene, there are the clouds that get procedurally generated from an potentially infinite texture. The way that's generated is using value noise. The first thing, the noise texture you saw in the middle of the screen was just some random on or off noise, right? So we've got at some interval in the texture space, we either have a 1 or a 0. By itself, that doesn't give you something that looks like anything. It doesn't look like clouds, it doesn't look like anything but static. You can scale up that noise using various interpolation functions. For example, a linear one would look like this, something like this, right, for the same sort of data and interval. And you can do some more fancy interpolation, more expensive interpolation, where it makes more of a smooth curve. And that means that you can scale it upwards in size without looking like boxes, depending on the type of interpolation you do. But it still doesn't look like anything natural, like terrain or clouds. So what this technique of value noise does is it combines multiple octaves of this noise. So let's say that we're just doing linear interpolation. We've got this one noise function over a certain scale. We're going to add to it some noise at a higher frequency, at a smaller scale, but also at a smaller amplitude. And then we're going to do that again. So we get noise on one scale added to noise on another scale. And eventually you get something that becomes looking more like something natural, more like terrain or clouds or water surfaces. You can do a few different things. You can apply thresholds different types of scaling. You can say that you're going to take the absolute value of the interpolated noise. You get things that look slightly differently. But that's the core idea. You're just taking pure noise and then scaling it down, adding it to other noise at different scales. Each time you scale it down in space, but also in amplitude. So that's what's happening over in the background there in the sky. But since it's an infinite procedural function, I run into this problem that after a certain amount of time, I need to say, okay, well it's got to loop at this point. Otherwise, it'll exceed the bounds of numerical precision. It'll start looking weird. The safe thing to do is to say, okay, after let's say 1 minute, whatever point it scrolled to, reset it. The alternative is to make it actually loop. In order to make it loop, we want the endpoints after a certain amount of time to match the point some distance beforehand. So we're going to say over a scale of 100 units, the entire thing needs to wrap up. And the way we do that is we're going to make the underlying noise textures we're using wrap, but not necessarily with the same scale of the overall wrapping. Every time we shrink the scale of the noise, we have to adjust the size across which it wraps as well. So we've got random numbers underlying it all in the noise, and as long as those which are inputs to the combined landscape we generate, combined procedural texture we generate, as long as the noise is wrapping at the scale we need, then the resulting combined texture will also wrap at that scale. In order to actually generate the noise, we use what's called a hash function. So we're doing a hash in over a point in space, right, over the dimensions of the texture. And what a hash function does is it produces bits that are as output that are fully determined by the input bits. But ideally, every bit of the output is changing a single bit of the input will on average change half the bits of the output, right? So it's extremely scrambled. The hash functions I'm using here are not ideal from that point of view, but they do go, they are quite efficient and produce reasonably good noise. So the texture that I was showing earlier is just taking the texture coordinate, scaling it by 128 and passing it to one of these hash functions. That's all the noise here. Alright, so I want to construct a version of this function that wraps in an interval that I control. Which one are we using? hash12. The hash13 version could be useful because it gives us an extra parameter that we can vary over time. So we can have a texture that's varying not only in space but in time. Other reasons to use an extra coordinate would be to get it's one way to get a smoothly wrapping texture around a cylinder or a sphere, for instance. Alright, what's the wrap interval, let's call it. So I'm going to do it the simplest way possible to start with. I'm just going to use a modulus, get the remainder after division by the interval size. And let's see if that works. And let's see if we can get it to repeat 4 times. The UV range is 0 to 1, and I'm multiplying that by 128. So I'm going to say the wrap interval will be 64. I kind of had to tell if that worked. Let's try a smaller wrap interval like 16. Spelling mistake. That's why it didn't work. Go back to Unity. Definitely hard to tell if it works. Let's scale it up. So I'm going to say the texture of just 32 bits wrapping at 16. Okay, thanks for the follow. Let's continue scaling that up. Let's say 8 wrap interval of 2, say. Interesting. I think I'll truncate the input so that I can drop some low order bits, and let's see. What we'll do is take the floor of the UV coordinate. I don't know if floor will be happy with a vector input. Excellent. So we're getting different effects in. I think I shifted my. Did I shift my coordinate space? Let's have a look at the code again. Yes. Well, I've got a separate noise. Okay. I'm trying to get back to a more... Okay, that looks more like it. Did I set a noise scale separately from the other scaling? That's just one. That's fine. So I'm looking at this right now. So that's repeating actually 4 times across, 4 times down. And that is what I'd expect from the code here. So let's increase that somewhat. So here I'd expect it to repeat 4 times. Sorry, repeat it twice on each dimension. And it does. It's a bit hard to see it when there's more noise, but you can see that you know, this sort of part repeats in each of the quadrants. All right. I'm going to bring in the code that then does the so value noise is the part where we scale up this noise texture, and then combining several octaves of it is actually called fractal Brownian motion. I'm going to bring in some code from the cloud shader. Into this texture that I'm currently authoring. I'm going to tell it to use our hash 12 above as the noise. I'm going to add the wrap interval there. So I'm going to keep the floor function because it lets me zoom in. I mean, it's one way for me to zoom in and see what's happening at the pixel level. So we're going to have let's start with the same parameter, 32 times UV coordinate, and then we'll have one extra parameter because this one takes 3. Just put 1. arbitrarily. I think it might not. One of the hashes I think does poorly if you set the value to 0, and I don't remember which one. No, my mistake. That just needs to match the dimension of the hash. So tell you what, I'll just go straight to the 3-dimensional hash because I'll make use of it later. Alright, so we've got a parameter h. H tells us how much we scale down the amplitude by. That's right. Peak 2 is a good value. And then the wrap interval and the number of octaves I'll leave to the default. Alright, let's see if that does anything. Got some kind of vector error. That's just copy paste error. Copy paste error. Almost there. What was that error? Cannot convert from vector float 2 to float 3. Oh, that was the missing one. It's not okay, not that track. Stick to non-vocal tracks. And then I already have that declaration of the IQFBM function, so I'll introduce. I can't overload it, so introduce a new name. What's the end goal with streaming, and what do I plan to do with the aesthetic? Streaming and VTubing is just a really good way for me to combine various hobbies that I've already got, right? So programming, 3D modeling. At some point I want to actually make some of the music myself. I've done a bit in the past. It's not exactly great quality yet. There's a lot of stuff that I'm interested in that I can just throw back into the streams. In terms of developing the aesthetic, I guess I've got quite ambitious goals. I want my stream to end up looking like a re-rendered CGI TV show from, you know, the late 90s. That's sort of the goal. With thoughts towards, you know, parts of, you know, bits of it going in a kids cartoon direction, bits of it in a TV show direction, Space Ghost, who knows where I'll end up exactly, but I have a very long list of ideas that I can't realize yet. What are we doing? So for now, back in Unity, we've still got noise because there's not a lot of pixels to work with. But if we scale that back up, let's see. A claymation stream. That would be very cool. You don't see a lot of claymation these days. Let's remove the floor call and see what happens. Right, interesting. Let's continue scaling up. So the one thing I'm not certain of is what the range of numbers I can feed into these noise functions and still get reasonable results. Could be that they expect, you know, only numbers 0 to 1 to actually work. Could be that they expect a much larger range. Okay, so this is interesting. I've only told it to repeat at oh, I've already, yeah. Okay, no lyrics. I need to remove things with lyrics from my playlist. Try that. Yeah, I'm based in the UK. And yes, I have seen Wallace and Gromit, if that's where the conversation's heading. So I forgot what I said earlier about scaling the wrap interval based on the shrinking of the noise. So that's one reason this is not looking ideal. I think the other reason is I'm exceeding the sensible domain. So to apply that first part, so F is the scaling we're applying, and we're doubling it each time, so we're going to double the wrap interval. And let's already look at what that looks like. Oh, and I'll also extract the scale here. And then the wrap interval will be in terms of the scale. Nightmare Before Christmas is an impressive example, yeah. Quite a different style. Okay. Interesting. It looks no different. So the amplitude e to the minus 2. No, I want 1, right? Hang on. Working backwards. I want the amplitude to be halved each time as a baseline. And here's the amplitude. Starts at 1. Second time around I want it to be a half. So G should be a half. And that's 2 to the power of minus 1, so H should be 1. Okay, well, it's obviously made a difference. I think we need to zoom in the scale. Let's go all the way to 1 from 1024. That's more like it. That's some of the effect that I expect to see. Hard to see the code on mobile. Let's head back to Visual Studio. I guess that would come up quite small. You can zoom in. This is about as far as I can zoom in and still fit in what I need to look at. Let's go to 4 for the scale. Now the other thing is, right now we're adding all of these layers of noise. What I think I'll do is have it automatically scale the maximum. So I'll say calculate the maximum possible value. Is max reserved. I'm just going to take T max. So here the maximum is going to be A times 1. So plus equals A. And at the end, oh, there's a bit of extra code here to do with the idea of fractional octaves. I'll ignore it for now because as long as we use the default number, it won't come into play. So I'm just going to say divide the result by T max. All right, good. That's what it's supposed to look like. So discovering the proper range for the values and the scales at which we get a good numerical result is part of the challenge here. So now, in theory, we should be able to see wrapping behavior. Now one thing is I noticed I don't think the wrapping that I was doing there is correct. So I think if I switch back to Unity, I think we'll throw a texture that does not look wrapped. Right, so I've modified the scale to make it, in theory, repeat several times across the interval. Now if I do it again, we might get several repeats in each quadrant, but hang on, why is it not? Nothing's happening. So our scale is 4, and then within that domain where we should be wrapping every 1 unit. No compile errors. num octaves is the default. I'm just passing 3 parameters to this specific function here. Oh, I'm staring right at it. I wasn't calling the right noise function. There are 2 different call sites. Let's try that again. We might discover that we need to apply a different scale to get good results. All right. As you can see, we are getting those repeats at least. So let's think. I'm going to try modifying the underlying scale and figure out. I could be seeing seeing these patterns could mean that I'm scaled in too far in, or that I'm scaled too far out. I'm just going to try a scale of 1 for a start. Okay, that suggests that we need to zoom out further to me. For a scale of 128. And now we're getting pure noise. Oh, well, with some patterns. I wonder. Oh, it's because of the scale. What I should be doing is what I'll do is I'll keep my scaling in the FBM function, but I will rescale what I pass in to the noise function. So the noise, the texture itself is rendered using this shader. Noise scale, this parameter is 1 at the moment. So I call this value at the moment compute a noise value, and then it calls my standard surface shading code and multiplies the result by the resulting color by the noise value. So the rest of the shader on the surface is just a white surface. And this function, we call into here, we do several octaves of noise, calling into this one, and F is a scaling parameter. And so what I think is, that P3 as a value needs to be scaled by some amount. So I'm trying that. That's also not a great noise pattern. I'm remembering now. So why do I have these particular hash functions there? They're purely using dot product and multiplications and additions, and so they're not, in theory, they're cheaper than when we were getting the good results. It was using the IQ noise function which doesn't. No, I've just realised that I don't have. I'm missing. Let me bring up the code. The underlying hash function for the IQ noise is using a sine, and I found that it had bad. Seemed to have a bad wrapping behaviour over the sort of intervals I was interested in, and in theory it's expensive because it's using a sine rather than just multiplications and things and additions. I'm only explaining it like I feel like I don't yet have a good grasp on it either. I've just been staring at it for a while. So what I want to do actually is I forgot the part where we do a linear interpolation of the noise. Now this one relies on a one-dimensional hash, but we're going to do a version of this that works with 3 dimensions. Call this noise 1 3. That means 1 out 3 in. So what this is doing is interpolating between the 8 points in my diagram. In 1D we have these individual sample points of noise, right? That are either 1 or 0. And in 3 dimensions we've got 3 dimensions of noise, values that are 1 or 0, and so we're going to find the corners of a cube that are either 1 or 0, and we're at some position inside that cube and we're going to linearly interpolate a value between 0 and 1 based on how far we are from these corners. Some of the right, I talked about smoother interpolation. This is doing that. It's instead of doing a fully linear interpolation, it's doing a bit of a it's using a little polynomial to do an ease in and ease out sort of thing. And then instead of using a 1D noise coordinate, I'm just trying to think right now how to express the so this is kind of combining some of the hash behavior and the scaling. Probably efficient in that respect, but okay, let's say float 3. This is a technique I've seen. Float 2e equals 0, 1. This is a way of kind of shrinking the code. We're going to have a lot of offsets here to express the corners, and so by saying e.xyy, we'll say offset of 0, 1, 1. Using the what's called the HLSL, is it Twizzling, I think. So f is our f is still three-dimensional vector here. It's how much we are in each coordinate, how far we are within that cube in each coordinate. So the actual hash we're calling is going to be hash13. We're still going to have our wrap interval. And here, so lowest value every integer. And then interpolated at fractional values. So hash13, we're just going to shorten that to w, the wrap interval, and the value is x. And then it's going to be x plus. What am I doing with the noise? Well, it'll become my clouds and my water displacement by having it wrapped after a controllable amount of distance or time. I'll be able to have smooth transitions between scenes that have very different skies without any kind of skipping effect. So that way I'll be able to do whatever I want with the speed of the sky and the water and the style of them, and then just fade smoothly from one to the other. Yeah, all kinds of effects potentially. So here we've got e.xx, and then we'll have the same thing but moved over in the x dimension. That'll be e.yxx. Okay, and then here we're interpolating by y, so each of these, this is confusing to explain. When I'm writing x here it means 0, and when I'm writing y it means 1. And I'm just offsetting each of the coordinates in these interpolations. LIRP stands for linear interpolate. I'm offsetting them to get the coordinate of the corner. No. So now we've got 8 different corners, 8 different combinations of X and Y. And we're interpolating that within that cube that I drew earlier. And so also we've got some rounding for what the actual scale of the float 3 that we pass in is. The noise function is going to have a different discrete value for every integer coordinate. And so here we're going to call noise13. Okay, let's see if I made any mistakes. Yes. That's a float 2. Okay, so doesn't look great right now. I'm going to play with the scale and see if we get good results again. Ah, thanks for hanging out. I'll see you around. Welcome anytime. So, eyeballing everything, checking what is the scale of what we pass in. Are we calling what we expect? I'm going to specify the number of octaves as 1. I think 1 is the base case. Have so last whole octave, floor of 1, I equals 0, I is less than 1, so we'll go around this once, and then the fraction will be 0, so although we'll run this, we're not gonna, the value will be irrelevant. Okay, and what that'll tell us is the base case actually doing what we expect? Which, because we're passing in a value from 0 to 1 and multiplying it by 4, I expect to see 4 different values. Let's put back the scale to 1 as well. So we should see something that's linearly interpolated across, see if, you know, around like 4 different values across the texture. Absolutely not the case. All right. What's going on? Bearing in mind that even if, oh, of course, I'm passing in X, I need to be passing in P, the value that's been rounded, because each of these coordinates needs to be at one corner of the cube. Okay, all those values could be 0. I might need to scale what I pass into the hash as well to fit into the useful range of the hash itself. I'm just going to change that scale value somewhat. Okay, well, I need to establish what the scale of values is that works well for the function hash13. And once I do that, I can scale the value that I pass in appropriately for what we need for the steps after that. Okay, I'm going to go to BRB and refill my tea, and we can tackle that. All right. So I'm going to go back to just using the hash directly. To figure out at what scale we get a good hash behavior from this function. Why is it not? There we go. So we have a float 3 starting with the UV and 1. The scale is going to be, the wrap scale is going to be scale, and yeah, that will do. Start with 1. Here I expect UV is 0 to 1. We're doing a floor. So we should just get 1 value. And now the texture is black. I don't know what I was expecting, really. That's it. So now let's say 8. Change the scale to 8. Nothing. Is there a compiler? I didn't notice. No. Now the one that I'm passing in is not necessarily a good value to pass in either. But stick with it for now. Try upping the scale. Let's go to 128. Okay, still black. We'll try in the opposite direction. Scale of 0. Well, no, that UV is 0 to 1. So if I scale it down and take the floor, I'll reduce everything to 0 anyway. 1024. There's something. Okay. So we see an obvious repeating pattern. I'm wondering right now, do I need to apply my scaling? I think I do need to apply my scaling after taking the floor. So let's think about it systematically. So at a point we apply scale to the UV. So this is the UV scale, and then we'll have a hash scale. So the first one of these is going to tell us how zoomed in we are to the noise space. The second one is how much do we scale the position value that we pass into the hash itself. And the hash scale is what we have to pick so that we can get good results. So UV scale will just tell us we're going to have let's say 256 by 256 samples. And then the wrap domain is that right? For now I want to not see any scaling, so it'll have to be a value at least that large. Sorry, I don't want to see any wrapping yet. Okay, we've got something, and now I'm going to vary the hash scale. So is that 256 samples? Let's do fewer so we can really see each sample value. It's not always supposed to happen. Interesting. That was 256 that was working, so 128. Does not work. 256 worked, 512 works. I'm going to try some non-power of 2 value. Interesting. That was 3. What did I pick? 350. If I pick something like 12. Okay. I'm gonna pick a... I'm gonna comment out the part about wrapping, the wrap interval, but right now. Oh, I added a scaling to the... Let me show you what I'm doing. I added this scaling. I don't want that. I'm also commenting out the wrap interval functionality right now as I determine the correct scale for the input. That looks more like what I'd expect. And now this music is distracting. What are we doing? So that was a scale of 12. So I was observing that 128, for example, was not producing, it was just producing a purely black texture, but this time it works. It's obviously not pure noise. There are patterns that we can discern within this. But it's reasonable. And so here the hash scale is 1. So we're taking 128 samples. I think this is a good scale for the UVs. And the hash scale could be varied. So I'm going to change it to 2 from 1. Do I notice more patterns than before? What should I expect this to look like? I'm trying to decide whether I'm suspicious of the grey values that we're seeing. I'm calling the hash directly at this point, aren't I? So I was expecting the return value to be let's go back to the code that did what looked like what I expected to, right? The hash returns a value between 0 and 1. Not 0 or 1. And then we interpolate these values. Still get something just between 0 and 1. So interpolation. Okay. Let's change the hash scale. If they are values between 0 and 1, we're seeing a lot more 0s and 1s than I expected. A lot of patterns. Patterns are bad. They'll stand out potentially in the finished output. I'm going to try different scales for the noise. Alright, obviously bad. It's 256. Can easily, so 256. Jump to 1/64th. Jump to 1/16th. I mean, they're interesting patterns, but jump to 1/2. Jump to 2. I'm going by multiplying by 4 to scale each time. scale of 8. Um, 32. Okay. At some point we'll get garbage again. So I'll make a note that it was good. Seemed okay. Seemed okay with scale of maybe 2.0 2, and then we'll figure that out what the 2 is. Let's go to 128. Okay, similar characteristics, I'd say. I'm not doing a rigorous statistical analysis. I'm just eyeballing it. 256, 512. Still looking good. 2048. Still looks fine. 4196, 80, 8. 8 times 10 to 24, whatever that is. That's gone beyond the powers of 2 that I have off the top of the dome. So that seemed okay with range of 0 to 128, scale of 2 to 8096, 2 to 8096 at least. So that gives us a fair range to play with. It's slightly anxiety inducing music. I just got a big playlist of I downloaded essentially the drum and bass in video games YouTube playlist, and then I'm removing anything that isn't quite suitable for the stream. Mostly anything annoying or has too much vocals. Okay, so look back at the code. Our underlying hash function. Oh, okay. Let's investigate the wrapping. First of all, I'm going to go back to a scale of 2 and make sure that the wrapping behaves as I expect. Not that one. So I'm going to divide by 4. So I expect 4 repetitions in each dimension. Bring back Unity, I think that's correct. Sometimes it takes a while to... Oh, there we go. So I'm visibly noticing a pattern that repeats 4 times in each axis. So I think I can leave that part in. I might introduce a wrapper function for my convenience. I'm not gonna use hash12 for now anyway. So I'll wrap the value first within the specified interval and then apply the scale and call the underlying hash. Is this what I want to do? I'm trying to think whether do I need to. So when I'm calling noise13, I get a noise value every integer. I'm wondering whether I simply want to call noise13 with a scaled value and wrapping interval. I can always apply the scaling outside the function that I'm calling. I can't always apply the wrapping because the wrapping interval has to scale with the space scaling we apply to this here. Let's go back to this. So when I said it seemed okay with range of 0 to 128, scale of 2 to 8096, what's the correct way of expressing that? That was with integer UV range of 0 to 128. So we're drawing 128 samples with values that were 0 to 256. Right. So we multiply the UV scale, UV is 0 to 1, multiply that by scale 0 to 128. So we took a floor, so we're drawing 128 discrete samples within our range. And we scale that by 2. So The scale tells us the interval that we need between our samples of the hash function before while still getting no visible patterns. So samples every 2 to the 1 to 2 to the 10 11 12 13. How does that answer what I was wondering about earlier? Let's call the interpolated version. We still have the floor in there, so actually it looks the same. But now we'll remove that. No, that's not right. I need an extra scale. So or maybe not. Maybe I'll say floor X divided by UV scale. Hold on. So I'm thinking the hash function still needs to get the noise 1.3 takes the floor and fraction parts. So when I was already passing in the value that's been floored, that's no good. I still want to apply a scale to what we pass into the underlying hash. Trying to figure out what extent I want to thread parameters through. We'll just say, okay, this hash will be in this particular range. Get the code back up while I'm thinking through this. In order to see the interpolation of the noise, the value we pass in, we want to vary smoothly across the UV values of the texture. So we don't want a floor call here. But we do potentially need a scaling in between the floor call and the actual call into the hash. So I'm gonna apply the just a value. I want it to vary smoothly. I'm going to not use a hash scale here in what we pass in, but just in move it back into the hash function itself. See what happens. Okay, well, it looks like noise that's being linearly upscaled. And so if I increase the scaling we apply to the hash, it shouldn't change the linear interpolation, it's just a scale of the noise. Okay. And then change my UV scale. I mean, we could almost just say that samples every 2 to the 0, every integer, right? Hash scale of 2 is not making a huge amount of difference either. Therefore what? So I can vary my UV scale and let the noise do its thing. So I can zoom in further to the noise. It's a bit too much. So we've got a repeat of 4 times across and down. And that's what I expect. So actually the conclusion is I can remove the hash scale, but now I understand that the underlying function, hash function, shouldn't be sampled at intervals smaller than 1. We've got the noise. So now we have that, we can go back to the full FBM. And see what does that look like. So not very exciting is the answer. So here we're still looking at 128 samples. But we're adding additional octaves of noise. And so in the end, what I expect this to look like if I switch to the other known good function, let's see how this one looks. Oh, I'm doing 1 octave, aren't I? Shindigs, welcome, good to see you. Not my most exciting stream, but I'm getting a handle on these procedural noise functions, trying to understand them well enough to make them behave and wrap at an interval that I control. So this is the known good in inverted commas, but with parameter values that are perhaps not ideal. And so we've got x, h, num octaves, and I'm passing in h of 1 is fine, num octaves, let's go to 5. Interesting. That's not scaling the way I'd expect it to. Let's say 0.5. So this is procedural value noise, it's called. So we're taking random values 0 to 1 and then interpolating them at a certain scale, and then adding on noise at a smaller scale, and then at a smaller scale still. Speaking of which, let's try a different scale. Okay. I messed with this before the stream and on Shader Toy, but what I'm doing is trying to really get a handle on the result. So value noise is actually the easiest to explain, least good results, but in particular you can see, although this looks like cloudy now, you can really see the underlying grid with gradient noise and other types. That's less apparent, but if I figure out the behavior I want on this example, then I hope I can transfer that knowledge to other kinds. So this is looking more correct. What happens if we call our wrapping Woven with the same number of octaves and same scale? Okay, I think that looks you know, plausible in the range of what I'd expect. And then if I say, I don't know, 4, the value. Yeah, that's the sort of thing. 8. So now let's change this and tell it to wrap 4 times. And it does, good. And it's wrapping continuously, even though the pattern is apparent, the exact joint point isn't. So you might say, oh, is it in this? Is it there? Is it there? There's different points that stand out, but there's not one edge that you can see is where it meets the other side of the loop. And what that means is that if we say what did I name my time variable? What did I know my time variable? Alright, yeah, okay. I think I still have wall time. Let's use sky. Right, this stuff I need to look at later. Boabadina, good to see you. Welcome and thank you for the subscription, resubscription. Yeah, PNG Woven. I am doing some more coding, and it's not impossible to have a non-PNG version of myself running at the same time I'm fiddling in Unity, but it is at best confusing in terms of the setup. I'm trying to this work will in the end mean that I can smoothly transition between different scrolling speeds of skies and also create more elaborate setups involving procedural textures. But we're really down in the weeds here, looking at some procedural noise textures. So ignoring this, which is going to be used for steps further down the line, I think I still have, yes, wall time seconds. Wall time seconds is the name. So I'm going to now add some scrolling. Say 0.1 F, 0.2 F. Hang on, what's the scale I'm working at? Well, let's have a look. How it looks. 0.0, because now we can add a bit of third dimension noises, scrolling as well. So if we go back to Unity, all right. So now we've got a texture that's scrolling, that repeats on an interval we control, and also we're using the third dimension parameter to vary the look of the texture over time. And now the important part is that so in this setup as it is, I'm passing in the current time to the shader, and it's using that as saying, okay, well, here's my speed of scrolling. It's adding that to the initial position, and although we're wrapping internally that position, there'll be a point where we hit numerical precision issues. I don't know how much it will show here, but what I can do is try to simulate that by saying, okay, well, what happens after 10,000 seconds have passed? What does that look like? That's not red. That's not a big enough effect. I'm gonna keep adding. Alright, in this setup and with the wrapping, it's perhaps less apparent. Oh, here we go. That's good. I've made it ridiculously large, and now you can see the numerical precision issues kicking in, right? So supposing I had the app open for a very long time, the wall clock time would become a very large number, and we'd run into these issues. So instead of doing that, and this is how the current sky shader and water shader scrolling that you see works right now in the background of the scene. So instead of doing that, I want to maintain an offset of how far we've scrolled so far. And I want to be able to say, okay, well, if we've scrolled more than, say, 100 meters or something, then wrap that value back around to 0. And then each frame we're adding on a bit to the scroll distance. We never run into that issue, but we do see a reset after 100 meters, right? But if we say that the function, the underlying function, should also wrap smoothly over 100 meters, And that's making me think now that maybe I need three dimensions for the wrap interval in space and time. But if we say that, then we can wrap without any visible jumps. Right. So I'm not going to bring in those extra variables just yet. I'm going to simulate it. Oh wow, I've been streaming for a while. I'm not dying yet, but I might still need to wrap up soon and you know, get food and all that. Okay, let's see. Let's try to get just a bit more done. So I'm going to pretend that this part is done outside the shader. The shader can't save any values. And I'm just saving time and brain power having to worry about the other side of the code for now. So we're going to say we're maintaining some offset and some speed with which we scroll, and finally I'm going to say, well, it's the range of each value. Okay, and so let's get these numbers the right way around. This music's not bad, but I need something more. Something that encourages my neurons. This'll do. We've got some range after which we wrap. And I'm trying to think how that correctly relates to the other scales we've got going on. So the actual UV space of the texture is 0 to 1, and my range I want to be actually several times the range of the texture, right? That 0 to 1 space is going to be a viewport we have onto the infinite, potentially infinite domain of the procedural noise. But I wanted to scroll by and not obviously repeat, but after a while it'll have wrapped around to a value it was at previously. And that doesn't have to be the same value for each of the 3 coordinates. So the UV scale is 8, which means that actually we're scaling the values, and across our view we're getting a range of 0 to 8. And then our wrapping range that we're passing into the function right now, I should just make that, I should directly make that a float 3. Okay, so we're going to pass in something proportional to p range to the underlying function. So p range times UV scale here equals x plus the offset. The offset is going to be speed times wall time seconds modulo E range. That should work. Okay. Oh, well that visibly okay. Kind of cool to look at. But obviously not working as intended. So what's happening here is every 10 seconds. Oh no, different rates in different dimensions, that's why. So for a start, it's every 5 seconds. So we're gonna set the speed to 0.2.20, and at least we should have exactly the same behavior every 5 seconds. Okay. So the offset in texture space is wrapping. I bet the problem here is no, I don't know. So X is scaled by the UV scale. Not the issue. Just try this. That's weird to look at, but I mean, somewhat correct. It's wrapping on a much smaller scale in space than I'd want it to. Right, I think I'm seeing it. The value the range over which it wraps has to be larger than our view. What happens if I just increase the UV scale for a start? No, that's just garbage. So the good news is we don't see any jumps. Right, after 5 seconds, we've wrapped around the position. Can I just modify the UV scale? So let's say 0.25. The value range we're getting is a bit weird. It's not in the range of 0 to 1 as I'd expect. But that could be to do with us being zoomed in on an unfortunate part of the coordinate space. Oh, I see what I need to do, I think. So 8 was a good value for the UV scale. Do I just need to extend the range? I'm trying to keep there's a relationship here between the wrapping time and the wrapping distance in space that I'm not correctly I'm not making the mental link here. I'm going to try this, right? So I've increased the wrapping range. Well, let's times 8, but also this one times 8. So what does that mean? In terms of the speed, it means we're scrolling 8 times faster. We're still wrapping after that same amount of time, 5 seconds. But in terms of the spatial range across which we wrap, we've extended it by 8 times. That's looking better. That works. That's it. We're getting the same clouds. But it's wrapping smoothly. So to make it more cloud-like, I'm just going to say is my inverse lerp accessible from here? I think I've got it in. Shader library, math. So we're doing it inverse lerp. We're saying no, I don't want lyrics. The lerp is mapping from the range 0 to 1 into some new range. So the inverse lerp, we're taking a larger range and mapping it into the 0 to 1 range. What's my order of parameters? The value is last. So noise is last, and we're saying we're essentially taking thresholds and scaling in between. 0.5 to 1. No, incorrect. Need to do that. There we go. And we can get some, we can just adjust the initial offset. I can add different speeds in different dimensions. Okay, that's a bit too fast for the third dimension. Let's try 1/10 of that, just to make it vary over time. Still a bit fast. Still a bit fast. Let's try 0.003. Ooh, there was a jump. Hang on. Was that just of a jump because of a reload, or no? Okay. Is it because I've got a negative value in here? Let's try 0.1 instead of negative 0.1 for the speed. Okay, that seems fine. So I need to look into what happens with negative values. So now we have got a slight evolution of the clouds over time because of the third dimension parameter. It's a 3D noise texture. So even after it's scrolled through the quite, short repeat we get here every 5 seconds, you actually get slightly different clouds the next time around. So the characteristics of the noise aren't ideal, but that's something that can be addressed separately, hopefully. Alright, can I now plug in the actual sky scrolling? Because the problem here is, right, if we... The problem I showed earlier with my sky scrolling, so I'll show it again. Hide this. I'll switch to my fast scrolling sky. It just goes all over the place for a bit. It looks like it's going one direction and then reverses. Because of the way it wraps and scrolls is not ideal. So this is the end state we want. What you'd want is the sky to look like it's accelerating smoothly up to the final speed and direction. But instead you get, very strange behavior. Don't know why it ends up totally blank. I think that's to do with some half-finished code I've got in there. Okay. I really need dinner, so I'm going to call that a success. The success being this noise texture that's smoothly scrolling, that wraps in space and time without any jumps. And because I've not got the code that maintains the scroll offset on the C# side hooked in yet, I can't actually demonstrate that setting the time value to some very large number will still give reasonable results, but there's every reason to believe that will be the case, and I'll get there. I just need some food first. I'm going to end the stream and send you off to see someone else. Just going to take a screenshot and let's see who we can raid. Well, to stay on the development theme, Woody Devs is making a VR game in what I must assume is going to be Unreal. So I will send you over right now. Let's see. Raid Woody Devs. with that said, thank you so much for watching. It's time for me to go. If you, like me, have caught the Millennium Bug, make sure to watch the next stream or find me elsewhere on the World Wide Web by clicking on the links below the video. I've been Millennium Cyborg, keep that future vibe, and I'll see you in the world of tomorrow.